Hello everyone. In this video, we will focus on the RSM model development. And as our previous video, we already conduct every model and also buckling analysis for the model. And from the data that we gain from the ANSYS, we will be using it for our RSM model. So of course, the same paper, which is Journal of Mechanical Engineering, and the DOI also is right in the description. So for the RSM model, we'll be using Design Expert, and we'll be generate 27 experimental run. For the OE, we'll be using full factorial design, and also will be apply modified polynomial regression. So let's go. So we start with new design. Okay, for now, I already have my dataset that I want to use with 27 samples run, which is also I'm using FFT, statistical design, which is full factorial design, which means all of my sample have a different combination of 3 factors. And I also have one output, which is buckling load. Okay, so first I will teach you how to import the dataset into the RSM. We just click the import dataset, and we can see it state that we need to paste from the clipboard. So you just need to copy the table for the 3 input and 1 output and just paste from the clipboard. Then we can change the column type. So I have 3 factors. So we start with the first factor, second factor, and third factor. And I have 1 output, which is the response. And also we can change the names. You just need to right click. Okay. So first is angle or orientation. Degrees. Next is the volume fraction. And the factor is plate thickness. Meters, and this is for the output. So my output is buckling load. Newton. After that, we just select finish. So all the dataset from the Excel has already been imported to the Design Expert. Now we start the RSM development model. Just click the analysis, then just click start analysis. Okay, so from here we can also select the regression function. We can choose the regression function that we want, for example quadratic or cubic, and it also gives us some of the result, which is the fit statics and also the p-value for each term. As it states, the p-value less than 0.05, each will indicate that the model term are significant. So to improve our model, we need our p-value is less than 0.05. As you can see, we see that the AB term, we have some of the term have higher p-value than 0.05. So we can conduct a modification for this model by just adjusting the terms. You can turn off or turn on the model terms. For example, if I want to close the a power of 2 and also b power of 2. I just need to double click. Then as you can see, it will remove some of the term, but also increase the R2 value. If the R2 value is closer to 1, it means it have a good model development. And so, for example, in my model, this is what I have done, which I include some of new term and also remove some term. As you can see, the p-value is less. Most of the p-value, or every p-value, is less than 0.05. Then for the next step, we will need to use the finite equation. For the finite equation, we can calculate the predicted output for the RSM value. For example, okay, this is the final equation. So I just need to use the Excel by including all of the information, as you can see, and then I will get the output for the RSM value. Then after that, you can compare the actual with the RSM output, the predicted RSM output. Other than that, RSM also, the design expert also give us some graph that can be used. For example, residual versus predicted, residual versus 1, and also it also provides some contour plot for factor relationship. You can change the terms to see the relationship between the factor A or factor B, factor P or factor C, and also factor A or factor B. And it also provide us with the 3D surface, which is also same. We can change the relationship term to see the factor interaction between the factor. So that's all for this video. Thank you.